Hello, you're welcome to today's lesson. My name is Harrison, and today we are still going on with latitudes and longitudes. We have a question on the board. An aircraft took 2 hours to fly from a town P, latitude 65 degrees north, longitude 45 degrees east, to another town T, latitude 65 degrees north, longitude 15 degrees east. The aircraft then changed its course, and 9 hours after leaving T, arrive at a third town Q. And the third town is at latitude 0 degree, that is the equator, and longitude 15 degrees east. If the flight from P to T was along the parallel of latitude, and that from T to Q along the meridian, we have to calculate correct to 3 significant figures the total length of the journey. Solution. The first thing we have to do is to, as usual, we draw the air surface and then indicate the points. So we have this. This is our north and south poles. And this is the equator. And that is latitude 0 degrees. So we now go back and check. The first one is latitude 65 degrees north, 45 degrees east. So let's take this to present that. And then this is 65 degrees north, and then 45 degrees east. Okay. Then to another town, T, 65 degrees, that means the same, but longitude 15 degrees. So if this is 45, 15 should be here, because as we are coming back, the longitude will be decreasing until we go to 0. So we have this. And then we use C to represent the center of the small circle. So that means we have our P here, and we have our T here. Now, the aircraft then change its course, and 9 hours after leaving T, arrive at Q. So, but Q is 15 degrees east, latitude 0. That means we are now talking of this place. And that should be our Q. Okay. So for this one, we are going to have this and this. Now let us start first of all by getting our angular difference, and then we solve. So bringing out this one should be 0. So we have this. Let's call this theta 1. And then we have P here. We have T here. So since we have east, that is, they are on the same side. And that means we have to for us to find the angular difference, we have to subtract. So theta 1 is equal to 45 degrees minus 15 degrees. And that will give us 30 degrees. So for us to find arc PT, arc PT is equal to theta 1 over 360 times 2 pi r, because we are talking of small radius. Since the distance is along small circle, that is from here to here. And that will give us theta 1 over 360, or we just put the value we already know, that's 30 over 360 times 2 times 3.142 multiplied by 6,400 cos alpha. Or we can write it as r cos alpha, okay? But r is 6,400, we already know. So this will give us 30 degrees over 360 multiplied by 2 multiplied by 3.142 multiplied by 6,400 times cos 65. Because that is our alpha. The alpha there is always the latitude. And then that will give us, we multiply out. And if we multiply out, we have we can reduce by having this 30 here 1, 30 here should be 12. So that means this should be 12. This should be 1, this should be 12. And then we need to find, so that would be, from there, I think we have to come up. We have to come up here. We have to come up here and then have arc PT is equal to 1 over 12 times 2 times 3.142 multiplied by 6,400 times 0.4226. 0.4226. Okay. And then moving on now, multiply. We have to multiply that out, and that will give us, that is to be 2 times 3.142 times 6,400 times 0.4226. That will give us 16,995.95776. We are dividing by 12. And if you do that, you are going to have 1,416.32. So, moving on. We can approximate and okay, we have 3298. 3298, that is, let's say 33 approximately. So we can now have it as 1416 point 1416.3 kilometers. That is the distance from P to T. So we have succeeded in getting the distance from P to T. So we can keep it somewhere and then go ahead and find from T to Q. So we have PT equal to 1416.3 kilometers. Okay. Then we are now going to check TQ. And TQ is along parallel of longitude. So we have, we come back. Now we bring it out and we have this. This is our T, this is our Q. Let's call this theta 2. So for us to find theta 2, it should be equal to, remember that we have from T to Q, 0 degree, 15 degrees, and then also to find the angular difference, it should be, we have along longitude, that's along 2 latitudes, 65 and 0. So for us to find it, we have to subtract 65 degrees minus 0 degree, and that will give us 65 degrees. So we have arc TQ is equal to arc TQ. Use the same formula, theta 2 all over 360 times 2 pi small r, which will give us 65 degrees all over 360 times 3.142 multiplied by 6,400 cos, should be cos 65. Cos 65. Okay, so please, there's a little mistake. Since we are talking of distance along longitude, we are not going to use small r. We are going to use what? Capital R. Why? This is our R and this is our R. Sorry for the mistake. So that means that will be easier for us. 65 over 360 times 2 times 3.142 multiplied by 6,400. Yes, distance along longitude will always involve capital R, while the small circle will involve small r. So we multiply out, and if we do that, we have, after multiplying this, we have, that will lead us to 614, then 144. We are dividing by 360. And that will give us 7261. 7261 approximately. So that is the distance from T to Q. But we are asked to find the total distance. And we know that the time taken should be 11 hours because 2 plus 9 will give us 11 hours. So in continuation, we quickly conclude by coming up here. There we have, therefore, total distance is equal to, we have to add the 2 from P to T is 1,416.3 plus 7261. 7261. So we have to add them, and after adding, this will lead us to 8677.3. 77.3 kilometers, approximately equal to 8,677 kilometers. So that is the total distance from P to Q. Assuming we are asked to find the average speed, you just to divide this total by the total time taken. So we have come to the end of the question. Please like, share, subscribe, and comment. If there's any question, you let me see it in the comment section so that I will look at it in my next video.